eksocad. All of our supporters, really. We have support from Itero. Itero provided the scanner for us. We have VHF that have provided the milling machine. We have Envision Tech that have provided the printer. Materials are coming from Vita, and components are coming from NT Trading. And all of these are my partner companies. So what I'm going to do today is I'm going to run through real life cases. I'm going to show you two different platforms, one of them being Chairside CAD. It's a platform that I use daily in my practice. And I'm also going to show you Exoplan. Now, Exoplan is eksocad's implant planning and guide creation software. But you guys are going to get a sneak preview, because what I'm going to show you is the absolute latest edition. It's Galway. Just bear in mind that what I will be showing today is not quite available yet, but as a beta tester, I've been allowed to show it to you. So we're going to really go through different complexities. We're going to do a very simple case. We're going to be milling live. My colleague Udo is going to help us with printing, so we'll be printing live as well. So let's kick off. So the first case we're going to do, I have a couple of models here. So this is a test model. What I'm going to do is I'm going to scan this as if you guys were practitioners scanning a real prep in practice. So we're going to use the Itero scanner to do so. Most important thing here is, because we're doing chairside milling, your support colleagues in whichever country you're in will set up your hardware so that chairside milling is an option there. So we select that first. Obviously up at the top there we put in the patient name. Here we're saying Insights model. And what we're going to do on this case is a lower right 6, so tooth number 4-6. And we're going to go ahead and do a crown there. We then get the option of choosing the material. In this particular case, I'm just going to say lab preference, and you'll see why later on. And the other thing that we have to enter here is a shade. So I will go ahead and enter my favorite shade, which is A2. So just to recap then, we've got the patient's name, we've got chairside milling, and we're telling it that we're doing a crown on 4-6. Go ahead and press the next icon, which will then activate our camera. And we will go ahead and start scanning. Now, what's really important while the scanner is activating itself is for you guys to know that when you're doing this kind of chairside dentistry, all of it is full ceramics. It's vitally important that as practitioners we're applying the right margins, so the right preparations, and generally it's going to be shoulder margins for strength of your full ceramic restorations. I recommend for people that are new to scanning and doing this kind of work that they're wearing good magnification, that they're using really good lighting to make your lives easier, because this is a realm where practitioners are taking the role of a technician. And you'll see what I mean when we get into the design element shortly. So here we go then. We are ready to scan, and the first thing that it's asking me to do is to scan tooth 4-6. Because I'm just doing a single unit here, I'm allowed to just go ahead and do a quadrant. So if you look on the screen there, then you will be able to see that it's asking me for the scan of tooth 4-6. Everything that I'm doing today here, guys, is live. Okay? So just like you might have attended the lecture yesterday with the live surgery, this is also live. That's my excuse for, sometimes things don't go to plan. Also, the floor is available for you guys to ask questions. Okay, so what it is it's actually scanning in HD right now, and that's why it's scanning slowly. This is the way it works with Itero, is that obviously they want you to have your prep scan in the highest definition. So that's done. If I go ahead and push the blue button, it's now asking me for the rest of the quadrant. I go ahead and pick up my scanner. You'll see it's going to pick up data much faster now because this is in standard definition. Oh, by the way, scanning protocol. I've used various different scanners over the years, and there is a specific scanning protocol to use with Itero as there is with others. So the way I'm scanning is the way that's comfortable for me, and you guys will find ways that are comfortable for you. What's really important is not speed. Please don't buy too much into what you see on social media. It's more about quality, because you guys as practitioners will have to use this data to go ahead and use it to create a restoration that you want to fit. So I would suggest that you concentrate on quality more than speed. But, you know, this is not exactly slow, so. Okay, so this is our opposing model. I don't need a huge amount of detail here, but I'm just going to pick up to the centrals, and so that's done as well. And the next thing it's going to ask me for is the bite registration. From a clinical point of view here, it's really important that the patient bites on their back teeth. Many problems over the years where patients think that they're helping you because you're about to put something in their mouth, so they think that they should open. They shouldn't. They should be closed, and they should be quite tightly closed. Simple things like that help you to ensure that the occlusion is correct and you don't have lots of adjustments to do when you're ready to fit your restoration. So this is the last of the scans here, and the purple coloration there shows that it has matched everything together. I click on the next button, and what it's going to do is start doing post-processing. Every single scanner has this facility, let's say, because what you were seeing on the screen before is unrendered data. So now the software, the hardware is all working together to clean up all of those images so that it's ready to be used. So what's happening here is that through a network, we have a connection between my design computer, the scanning computer, and the mill. So it would be a similar kind of situation in a practice as well. This color map up on the screen here is to show me the amount of space that I've got between my arches, and I need to just tell it to send the data across. So as I was saying, we've got a network connection here. That's why there are lots of cables. You could do this wirelessly in your practice. You could do it with a cable network as well. And it's set up so that all of that data is going to be dumped straight into eksocad. And we will shortly switch to the other screen, the design screen, and then you will see what comes up. Fantastic. Alrighty, so the data has moved across, and the way that we know is if we go to load, I've set up this computer so that it automatically pulls the data in. You can also do it manually as well. So as you saw on this scanning computer earlier, we call this the insights model. And if I click on load here, you're going to see a whole bunch of data on the screen. So this is the same data that I input in Itero. And this is important because it just means speed. It means that you don't have to input the data several times. So up on the screen here, if you can see my cursor, the patient name is there. The data that's been collected from the scanning computer is below, including the shade. Over in the middle here, this is what we call the job definition. And in the opposing arch, this is all orange, so you can see the legend in the middle that calls it antagonist. The lower jaw, we have the gold-colored teeth there, which are your adjacent teeth, and of course our working tooth, tooth 46, is highlighted in green. Now there where it says coping, if I go ahead and click on that, you're going to see all of the different things you could do with chairside CAD. So this is the standard format. I mean, there are a few options there like bite splint module, but what we're going to do here is we're going to choose a crown, an anatopic crown. Vita have kindly provided us with some beautiful feldspathic, so we're going to say feldspar. Over in the middle here, this software version of chairside CAD is specifically linked to the VHF Z4. So depending on what machine you intend to buy, and the software does link to several different machines, you would tell your reseller, that's what I want, and then they would provide you with the software that matches with that. So the VHF Z4 is a 4-axis machine. So let's go feldspar. And over on the right hand side there are a bunch of other options, but we are going to keep this simple today and click on OK. Bottom down here, scan mode, digital impression scan. That's basically another terminology for intraoral scan. If I go ahead and click on save, you will see on the right hand side on the screen a bunch of buttons have become activated, and we're going to go straight into design. So there are two elements to every single one of the eksocad software platforms. There's DB, stands for database, and then there's CAD, computer-aided design. So what we were just using there was the DB element, the database element. So that's where we can input data about what the CAD software should expect to receive. We're now in the CAD element, and you can see this is the data that I've just created from scanning that model. And the first thing that the software is asking for is the margin. Okay, I'm going to keep this case really simple. I'm going to zoom in. This is a supragingival prep, and if I click on one point on the preparation, you saw that within less than a second, eksocad picked up the entire margin. you have the option then of modifying that using correct draw. And you can see if I zoom in there that we have multiple different control points that we can move to just make it more accurate, modify things, change things. That's pretty good. I'm happy with that. So we go ahead and click next. So the next thing that the software asks us for here is the insertion axis. This is really, really important. When I'm teaching practitioners, this is an ideal area for me to show them things about preparation technique, and I'll just quickly run over it now. When you are a dentist and you're taking an impression, whether it be a physical one or a digital one, and sending that to a lab, often as practitioners we just think, they'll deal with it. This is different now. This is where your technical expertise have to come out as well. So the reason I'm highlighting that is that I've modified the position of the model, and you can see the prep has gone bright red. That's eksokad's way of showing undercut, physical undercut. So it's basically saying that if I did that physical, if I used that as my path of insertion, that the physical undercut would prevent me inserting that restoration. The other thing, if you look very carefully, if you look at the adjacent teeth, you can see a kind of golden yellow glow on the adjacent teeth. And that is what I call digital undercut rather than physical. Now, what I'm able to do by moving the model around is alter that. Now, the easiest way for me to describe that is that if you ignore that, you're going to have restorations that fit but potentially spaces around and black triangles, gaps that are unaesthetic. So what I teach my users is that this is an opportunity to make your life and the patient's life easier simply by adjusting adjacent teeth, smoothing fillings, and ensuring that you've got a clear path of insertion, obviously with the patient's consent. So we're going to go ahead and mark our insertion axis there and hit next. Now, there are a bunch of parameters working in the background, and those parameters just kicked in there. One of them is minimum thickness. If I just open DB again and click on the 4.6, you will see right here a couple of the parameters, and this is now represented graphically in the CAD software. Also, at this point in the process, in the workflow, if we had the contralateral data, we could copy the tooth from the other side. Or if you said, well, you know what, I really like that 7, I'm going to copy the 7 into the 6, you could even do that as well. Again, we're going to keep things simple here and just go forward by clicking next. The data is now proposing a tooth restoration. Now, where did it get that from? And I will tell you where that came from. Over here is our tooth library. Every single installation of chairside CAD gets 12 different tooth libraries available there. It will always default to the one that's called generic. Personally, I use this one the most. I don't tend to change it, but it's really useful for some practitioners to have multiple. So we've got our tooth from the tooth library. This is a really important step where we can help the software in positioning this proposed restoration. And the way we do that, the instructions are always on the left-hand side, and they're in small print. The reason they're in small print is it's there to help the dentist, but it's not necessarily there to show the patient who might be sitting next to you that here's the instructions of how to use it. It could get embarrassing if they're telling you how to use it. So what we're going to do is we're going to hold the shift button to scale the restoration and make it bigger. We can use the control button to rotate and tilt. And I can see the preparation underneath. It's quite a wide preparation, so I'm just going to move the tooth buccally. Okay. So that's done. I'm pretty happy with that. The pink area, the color, this is also very, very important. So let me explain. I've just clicked on the arrow up at the top of the screen where you can see the colorful legend up there. That describes what the colors mean. And there are a few different options here. There are contacts, intersections, and proximity. For anybody that's chairside milling, it's really, really important that they use the proximity setting, because proximity gives you so much more information. It also means that as a practitioner, when you're about to fit this restoration and adjust it, it's kind of helping you in lateral excursions as well, because the bite registration that we took with our intraoral scan was a static bite. It wasn't a dynamic bite. So if I change that to show proximity, you see a lot more pink. Pink is a big problem here because it goes off the scale that you see there. That means the contact is so high it's not going to work. Let's get some more data in there. If we click the button that shows include healthy, you get an idea as to this patient's occlusal scheme. Now I'm going to ignore the pink there on purpose. I'm going to hit next and show you what happens. This that you're going to see up on the screen now, this is another module. So chairside CAD has a modular structure, and you can choose to have this or not have this. That was called auto articulator. And what that did was it has just taken that proposed design and it has shrunk it down to the margins. So if I take off the antagonist data, you will see the colors have changed. And if I switch off the colors over here, show distances, you can see now we have a restoration that's adjusted to that bite dynamically as well as in static occlusion. Okay. Now it doesn't look so pretty, but we're going to fix that using some other tools in just a moment. Any questions from the room? Okay, so let's proceed. Typically, I'm going to show you how I do this. There's no right or wrong way, but the way I would teach this to be the fastest possible workflow is do your macro movements first. That means your big changes, and then your fine tuning, and then you should be ready to mill. We will be milling probably in under 5 minutes. So if I press the S button on the screen, it gets rid of my scan data. And my favorite tool here in freeforming is smooth. Love it. So I'm just using the left mouse button and tracing around the tooth, rotating it around. So I'm rotating it around using the right button on the mouse, and then the left button helps to use the tool. Now in clinical practice, I use both hands. So I use a space mouse on my left hand, I use my right hand just for the mouse, the regular mouse. Okay, so what I've done there is I've made some adjustments, and if you look carefully, you can see some pink areas there. And that's the software warning me that I'm encroaching on the minimal thickness. So it's warning you all of the time, making sure that you're not going to make a mistake. If we bring our colors back in here, we can see that we have tight contacts, a little bit high level in the occlusion, and there's an automatic tool to fix that as well. If we go to adapt, and we set our parameter to 0 here, and we ask it to cut intersections, you will see how it just dropped down the occlusion. And likewise with approximals, you can go ahead and ask it to cut intersections, and it will adjust that for you as well. Typically, I will fine tune it a little bit before it's ready to mill, and I will show you another couple of tools as well. So let's go ahead and use add remove some of these high points here, and make sure we're happy to proceed. Now here's the thing, because there are parameters running in the background, if I go ahead and encroach on those parameters, like for instance minimum thickness, the software will bring the minimum thickness back up again. And it's really important that you know that, because some of my users will say, well, it looked perfect on the screen, but I still had adjustments to do. So that's why I teach the DB element. And in the DB element, if I click here on advanced parameters, this is how powerful chairside CAD is. Chairside CAD was developed from the lab software that was around for 8 years beforehand. So it's important that you know as practitioners you've got a tool that's really, really powerful. However, the guys at eksocad have made it such that it's easy for you to use. So we're going to go ahead and click on next. And you saw that even where I reduced the height down, it brought it back up again. Doesn't matter too much. I've explained that's to do with the restoring minimum thickness. So this is not an advertisement for Vita. It's because I chose feldspathics there that is giving me the option of feldspathics that are available. You can see there's some GC products there. Had I picked, for instance, let's say lithium disilicate, you will see other materials arrive. So eksocad has worked with a variety of different partners, including all of those that I mentioned before, with regards to materials and all sorts. Let's go ahead and look at what we have here. So I have a selection of materials, so we will go with a Vita material. And I'm going to use something called Trilux Forte from Vita in a size 14, and this is an A2. So this is important to show you as well. It's another one of the modules, and this is the in-CAD nesting module. And what you can see here is that the software has proposed the restoration within the milling block. So I can position that accordingly. On the inside there, that is a sprue. So that's what the machine is going to hold the restoration with as it comes to the end of the milling, so that it doesn't drop it. So you can see the entire restoration within the block. Now I chose this material on purpose because chairside restorations in the past used to get a bit of bad press in our profession, and especially from technicians who would say, oh, they don't look like real teeth that a technician could make. You're going to see here, this is a restoration that's going to come out in 4 colors. Let me highlight this to you. If I change the visibility here, I hope you can all see the stripes in the block. And you can actually move that restoration up and down in the block. So it's not many of us that actually specify to a technician to make our crown in 3 or 4 different shades. But with these materials that are available, you can do it now. So I'm going to leave that in that position so that once it's milled, you can see it. We have options in terms of speed of the mill. So for today, I'm going to put it on fast mill and go ahead and hit next. So this is where the VHF Z4 comes into action. For safety reasons, we have to put a lot number in there and then hit next. So the Z4 is a 4-axis machine. It's designed to cut single blocks at a time, and I've told it what block we're going to use. So eksokad have worked with VHF in producing the software that links the two together. We have Christine here as our helper. Thank you, Christine. So what Christine's going to do is open the milling chamber, and she will apply the block. And on the screen, I'm not sure if the camera can show it, but on the screen shortly there will be instructions as to what milling tools to put in the machine, what block it is expecting, what size of block, what material, and it will also give us an estimation as to the milling time as well. So currently what's happening is the eksokad software is working through the milling strategy, and then it's dumping that to the machine. So it has now gone across to the machine. We have a number 1 on the screen. So it's saying Vitablocks Trilux size 14, and that's going to take 21 minutes to mill. And we are going to do this live right now. So we started at 2 o'clock. It's now 25 past. If we look at real-time scenarios, okay, I've been talking to you and I've gone ahead and scanned, I've designed, and I've got this ready to go to the mill. Excuse me. Okay, that's the noise we should have heard. It's a self-maintaining machine. It was asking me if I wanted to do the maintenance. A little bit busy right now, so we'll pause that for later. So 25 minutes it took me to scan, design, and get that restoration ready to mill. That's a molar, okay? It's relatively quick, and I'm talking as I'm going along. Obviously, you need some time for preparation of the tooth as well, and depends on what tooth you're preparing, what patient is, but right now we're working relatively quickly. I'm going to switch things up now, and we're going to go to a completely different type of restoration. We're going to leave the design software up there. If you can see on the lower left-hand side where it says producing, it's now dumping the data to the memory in that machine, and once it's done that, it will close itself down. For now, I am going to bring that screen down. Okay, I'm also going to speak louder now so that you can hear me over the machine. I've done this on purpose. I've left the machine running on purpose because most of my clients that are doing this, they have their machines in their reception areas. It becomes a talking point for the practice, okay? It becomes a wow factor. And in my practice, 17 years doing chairside dentistry, everyone who's got one restoration has got more than one. Because when patients see this and they get involved in it and they realize that they can be involved in the real-time design of their dentistry, watch things being made, they become invested in it. So it's a journey that you're taking them along. Okay, what we're going to do next, as I said, we're going to turn things up a little bit. With chairside CAD, there's another module called implant module. So we're going to show you that today as well. So we're going to switch back to the iTero machine. Okay, so we're switched over to iTero. And what we're going to do here, this is a real case of mine that I did a few years ago. It's a lower right 6, my favorite tooth to treat. And what I have here is I have some working models. So as if you had placed the implant already in this case and it's ready to restore. So in here in this model, I have a digital implant model analog, which has been provided by NT Trading. We're going to use NT Trading's scan body, which is really important. So you use a matching scan body to your implant system, and there are various out there. And of course, the iTero is well equipped to do these kind of cases. So let's crack on with a new case. So here, again, we're going to tell the machine that we're doing chairside milling. The difference being here, we're going to tell it that we've got a pre-treatment scan because we have the tissues to pick up, as well as the scan body, as well as the opposing teeth. Again, 4-6, but this time instead of crown, we're going to say implant abutment. we get a new screen pop up and we get a choice of materials. Again, we're going to go lab preference. Remember, the lab here is the dentist, right? So we're going to choose that in the software. We can go ahead and put in a shade as well. So we've got patient's name, chairside milling, pre-treatment scan, and the lower right 6, the 4-6 tooth you can see on the top right-hand side has got a diagram of an implant there, so it's clear what we are doing, and we tell the machine that we are ready to scan. Let's go ahead and pick up our scanner and scan this quadrant. So the reason I was looking at Christoph there is that each different scanner has a slightly different protocol for how you scan an implant case. So it's really important that you pay attention to their scanning protocol, whether it's going to be for lab side work or for chair side work, and you follow that properly and make your life easier. So what we've done there is a scan of that quadrant. You can see I've picked up the implant site. What's really important for me is that I pick up the adjacent teeth and get my contact information. Again, this is a technique thing, so I'm rotating the scanner in different directions to ensure that the light from the iTero wand is shining into the areas that I need to capture. So that's done. If I hit the blue button, it's telling me to take the opposing arch next. I think all of you would agree that even though that wasn't a particularly fast scan, this one's faster. It's a darn sight quicker than mixing a material, loading an impression tray and putting that in a patient's mouth. And I think because we're trying to build in this wow factor as well as accuracy, most patients would be very happy to have a scan rather than an impression. Okay, and that's done. Next is asking me for a bite registration. So again, we get the patient to close into intercuspal position, and we go ahead and do our buccal bite registration. And over here, what we're trying to do with the iTero is show it the upper and lower elements that we've already scanned so that it can bring it together. And it's done that really quickly. Again, it's gone purple, just like I showed you before, so that it says that, yes, I've got the data. Now we're going to go ahead and put in our scan body. Again, this is from NT Trading. Just happens to be my preferred scan abutment of choice. And the reason being that when you're scanning in the mouth, in fact, when you're scanning in a lab, let alone a mouth, it's really important that the scan bodies that you're using are isometric. Okay, so that means completely different shapes all the way around. The reason for this is when you bring these scans into data, into software, into planning software or design software, it's really important that you can see the various elements of that scan reference body, and you'll see that shortly. So go ahead, activate the scanner again, and you can see the scan body is right there. Now this has slowed down again because we're scanning in HD, just like we did in the tooth preparation earlier. So you have to give the scanner a bit more time in each area, and what it will do is it will give you a lot more detail. So you can see my picture building up there. That's the scan body. It's physically screwed into the implant site. And it's really important, especially if you guys are placing implants that are subcrestal, that you have a clear path of insertion into the implant. What I'm saying is that if that scan body hasn't been fully seated and you go through all of this process, that's how you get implant restorations that don't fit. And it's most common, I own a laboratory as well, it's most common we see in our labs when people have not fully seated their scan bodies. Okay, so the beautiful restorations look good, and the technician says, well, it fits on the model. And then the dentist says, well, that may be fine, but it doesn't fit in the mouth. It's often because of little things like that. Okay, now we're going to do a standard definition scan, again with the scan body in place. And what it's going to do, the way iTero works is that in areas of importance, it's going to take your high def scan and your standard definition scan, and it's going to overlay the two together. Okay, that's our scanning done, guys. So I push the next button on the screen, and again, it's doing its post-processing. There are more scans here, so it's going to take a little bit longer to complete the post-processing. And what will happen is, again, it will dump all of the data straight into my eksocad platform. I will check in DB that I'm happy with that, change anything that I want to change, and then I will go ahead and take you through the steps of design. And I'm hoping that we can also go ahead and mill this restoration as well. It's going to be a screw retained restoration on a tie base. After we've done that, we're going to go and start talking about a whole different software platform, which is Exoplan. So we're 35 minutes in, we're on our second case already, and yeah, we're going to get into some more detail now. The reason I started with a really simple case to start with is to show you that when Exocad's building different platforms, they try to keep some continuity between their platforms. So even if you went into a lab that was using an Exocad platform, you would see a lot of the same features. And whether you're doing a simple restoration on a crown, and then later on you go to your reseller and say, you know what, I can do crowns now, I want to do quadrants, and then you do that, and then you say, well, I want to do implant restorations, and maybe later go to do anterior restorations. It kind of helps you build through your progress. The reason we're going to bring in Exoplan later on is because, again, you'll see some of the same tools and the same techniques applied across them. So the guys, the developers have thought about this in producing the different platforms to ensure that their existing customer base doesn't have to relearn things. So currently, post-processing is going on the machine. It's sending the model data across. Let's have a look at how our milling machine is going. So 25 minutes done. It actually looks like a crown now, and it's doing the detail. I should tell you that the way it works with the VHF milling, as well as some of the others, is that even if you choose it to be a fast mill rather than a high quality mill, the fit quality will always remain the same. So it will never change the quality of the fit surface. What it does is it will change the quality of the polished surface, the external surface. So in this particular case, just for speed, we've asked it to do it on a fast mill, but you could choose high quality and see all of the intricate detail. I think then it really depends on how much time you've got on the case, what material you're cutting, and various other little intricacies like that. Let's have a look if our data's moved across. Yeah. Okay, so here we go. Second case of the session, and this becomes our implant case. Okay. Not this one. Okay. Okay, so this is our next case. I know it looks very similar, but if you look on the left-hand side, we've got different data set that's come in, and you can see that we are going ahead with an implant restoration here. So antagonist in the upper jaw, adjacent teeth in the lower, and our 4-6. You can see what's happened on the right-hand side. We didn't really look at this before, but where it says options and parameters, right up at the top, it says on custom abutment. And if you remember, that's what I chose in the iTero. So it seamlessly transit that data across. I'm going to just change that. I'm going to change a few things here. Vita's given us a few different materials, so we're going to use a hybrid material this time. So hybrid ceramic in our 4-axis machine, and we're going to tell it that it's a screw retained crown. Now if I look through that list, there are a whole bunch of different options there, including custom abutment, screw retained, the option to design to decide later on, depending on what you choose, depending on the data set that you see. There are certain milling machines, including this one, that can actually mill titanium abutments. So we have given, with chairside CAD, the ability to dentists to now actually design and produce their own custom abutments. And typically, that's done with what are called preform or prefab abutments. So these are manufacturers, in this case NT Trading, and there are others from DES and Medentica, all available worldwide, that have created prefab titanium blocks which go into these milling machines. Okay, so it's not just for technicians anymore, dentists can do it as well. And with the power of eksocad's chairside product, you can go ahead and design a custom abutment. Now, we don't have time for that today, but the option is there. We're going to have a screw retain restoration, hybrid ceramic. Click on OK. Happy with all of that, and save. As soon as we click save, our options light up on the right hand side, and we're going to go into design. Alrighty, so first question from eksocad is, well, which library are we using? We're going to use full library. I said to you earlier that I'm using the NT Trading, and it's the Breedent scan body, okay? And you'll see that it's appeared here in the window, and it replicates effectively what you've put in the mouth. Now earlier I also said to you while I was scanning that it's really important that you use an isometric shape and one that's easy for you to see the differences on each side. So if I rotate this around, you can see it's curved on one side, flat on another side. Lots of different scan bodies exist, and it's important that you recognize that there'll be a particular point on there that you have to point the software to. So eksocad's asking me to click on a certain point. I've done that. I click on best fit matching, and what it's done is it's overlaid its library reference data onto the actual data from the mouth. Okay, next we are asked for emergence profile of the restoration, and over here we have our soft tissue out here, so I can draw a line and I can say, well, the emergence profile, this is effectively the base of the crown, okay? Red lines, eksocad recognizes that that's, tissue that's much higher, so I can move those along. If you zoom in, you can see there are control points. If I decide I don't like something there, I can change it very easily, and eksocad won't let you create a line that's not something it can work with. Alrighty, so that's done as well. That's our emergence profile. Just like I showed you before with the other simple case, we now get the option of mirroring or copying. We don't have contralateral data here, so we can go ahead and click next. These are the similarities that I was talking about. So far, all of this is pretty much the same as you saw on the 4-6 tooth preparation. The difference being so far that we had to choose our scan body, we had to link that in, and we had to look at our emergence profile on the gum. Now this particular case, I need to move the crown quite lingual. I'm going to use control and just tilt it. Again, I'm using my generic library tooth, and I'm just going to scale that a little bit to make it bigger. Like I said to you before, I'm going to mill this restoration, so I want to see proximity data. I want to look at the adjacent teeth and what does the bite profile look like, what's the occlusion like. Do a bit of a rotation there and hit next. Okay, here in this particular screen, this is where we are doing something different again. So again, a difference between the restoration on a tooth compared to the restoration on a implant case. And where I put in the scan, the emergence profile data earlier, you can see that has now been used to create the base of this custom abutment. Okay, overlaid over the top is our proposed tooth model. So there are various tips and tricks here, and you can use these sliders to go ahead and very easily change the shape of our base of our abutment. So you may be able to see that if I zoom in, that the base of the abutment can be more concave or convex depending on how you would like it to be. We can take away that transition line, so it's a very, very smooth transition, and we can make a multitude of changes here to make this an absolutely customized abutment base for your particular patient. And that's why it's important that when you're scanning, you pick up the scan data of the soft tissue and not just the scan body itself, because this way you can decide, well, which way do I want to push the tissues? The tissues may not be fully mature, so you can decide that as a practitioner who has some new technical skills. When we go ahead and click next, you can see that base, abutment base, has now turned gold. That means it's locked. I can't change it at this stage. Auto articulator function just came in, and you can also see that we now have an implant analog in the base of the restoration. So all of the auto articulator mode has just adjusted my restoration for me. It's remembered the fact that I said, hey, this has to be screw retained, so you can see a screw access channel there as well. Now, fundamentally, the modification of this restoration is exactly how I did before. So, as I said, I like to switch off all of the colors, start with Smooth Tool. This is a good place for me to show you some more of the wow factor that you can bring in for patients. So, there's a module called True Smile. So, if I go ahead and activate that, you see that tooth as per the shade that I designated over here. Can you see bottom left-hand side, tooth shade A1? So you can actually show the patient that, well, this is pretty much what it's going to look like. This is a color scanner, but the model that I scanned was yellow, which is why it's looking up yellow there. So if you put this in the context of clinical situation where if you're using a color scanner and you can see pink soft tissues, you can see adjacent restorations, adjacent teeth, that's where TrueSmile comes into its own. And also really, it's a selling tool to help you sell more aesthetic restorations. So as before, I'm going to go around, smooth up the lumps and bumps, and use the various tools that we have over here in free-forming to make this a restoration that we can create. So I've purposely left the buccal aspect bulbous there because I want to show you how easy it is, really, really easy to modify these restorations. You really don't need to be a technician, you need to be a dentist that can think outside of the box and picture an aesthetic restoration. So let's put our scan data back in there, and you can see how the buccal element is quite bulbous, and I can literally grab that using this tool, it's called tooth parts, and just move it in and out. Likewise, I can go ahead and adjust my cusps up and down, left and right. So what I'm doing in a split second would take at least minutes for a technician to do, either with wax or any other conventional method. I have no doubt that most of you that are considering this kind of software and hardware combination are probably working with digital labs anyway, so for them this is everyday work. But for those that aren't, you know, we have some pretty powerful software here, which, as I said, was developed from eksokad's original lab product. Christine, would you do the honors and just take that crown out for me, please? It's a brand new machine, Christine. You have to pull hard. Thanks to Nicholas and Sven for providing the machine, by the way. They're from VHF. That's okay. Lovely. Well, Christine? Well, how about you show this to the camera and show our audience at home and in the room how that fits, and give them your honest opinion, please. So again, in the same way, we can nest our restoration, our design right there. You can move it around. In this particular material, if I go ahead and increase the layer visibility, this has got 6 different shades in it. Which of you as practitioners has ever put 6 different shades on a lab ticket to say to a lab technician, can you make it like this for me? I just don't think it's something that's really going to be financially viable. Maybe good for the technician. I can't imagine what he might charge you, he or she. That is now in its block. We're going to say fast milling again. Go ahead and click next. So the Z4 just finished a case, and it's literally going to be ready to do another one. And what it's expecting this time is the Vita Enamic size EMC 14 block. Christine, if you would be so kind to... Yes, please. Yes. So what Christine just asked me is, do I want to delete the previous job? This particular milling machine has a built-in computer, and it saves all of the mills that it's done. That's useful for a practitioner in case, for whatever reason, you need to remill a restoration. So they are saved both in the eksokad design software as well as on the machine.
I got first questions from the internet audience.
Fire away, Michael. What do you have?
So what kind of indications do you do chairside?
I am quite happy to do single posteriors, quadrant posteriors, anteriors. Me, generally, I'll do single anteriors without a problem. But my situation is a little bit different because I own a lab. I have technicians who work alongside me. So you can do multiple anteriors. I personally choose not to because I don't think it's financially viable. Unless you've got half a day or a day and you're charging the right fees. So it's really important that you guys realize I am a working practitioner. I do have to earn my money doing dentistry. So I'm not going to suggest to you something that's going to take you a lot of time and you're stressed out at the end of it. So for new users, Michael, I'm going to suggest single posteriors, moving to multiple posteriors. Then actually implant crowns have been made so easy with eksokad's new modules, so I would suggest that if they are restoring implants, to do that next and then go into anteriors. Anteriors require you to have a really good eye for morphology and symmetry. Now, that was the great thing about the mirror copy function in eksocad, whereby if you are doing a single anterior, and I have, dentists in the room and online will be able to know that actually the most difficult restoration to do is a single upper central on its own, right? Where the patient doesn't have the funds or doesn't want to cut an adjacent tooth to do symmetry. So that's difficult. This software makes that as easy as can be, and I think what becomes a more complex then is the choice of materials. So I know that's a complicated answer. The answer is I do all of them, okay? But at the right stage, it's about building your educational knowledge. There is a learning curve if you've never done any design before. There's a learning curve for scanning as well. So to throw someone in at the deep end and say to them that if you invest this amount of time, money and effort, you can do all of this, of course you can, in time.
Thank you, Gulshan. You already answered the second question, which was, are you still working with labs or do you do all in-house?
So I own a lab. So of course I work with labs, and actually one of the things I'd love to say to you guys is that chairside dentistry is not there. It's not there to kill off labs. eksocad's prime customer base is lab technicians worldwide. And Tillman may nod or shake your head. Prime customers worldwide are still labs, correct? Okay, so the last thing that eksocad wants to do as a provider is to say we're going to arm all these dentists with chairside CAD. Absolutely not. My lab bill annually is around about, in euros, probably around about 48 to 55,000 euros a year. Me on my own, small private practice. Plus, I do chairside CAD every day. Okay. I haven't got time to show you just now today, but I could show you the kind of crazy cases that I do with chairside CAD. You can see online I've published some of my cases. Some of the cases that I do with chairside CAD, with any kind of chairside software, Michael, they're cases that my technicians simply wouldn't want. They're deep preparations, 3mm subgingival. They are cases where, because I know I just did the preparation margin, I can see where it is. But no technician would want it necessarily. And I know that because they see my work. And they say, yeah, you keep that one, you know. So when I send cases to the lab, which I do regularly, I typically send them cases which are high value, multiple unit, lots of anterior stuff. That's the way I work.
So your lab get the funny stuff or the fun stuff?
The lab gets, look,
the experienced works.
my lab is called 4D ceramics, okay? The 3D part of it is 3D CAD CAM. The fourth dimension is the technician. I have absolute respect for my technical colleagues. Really, really important. And saying that though, my technician and his wife, both of them have restorations that I made for them chairside. So just like they appreciate what we can do with technology, I appreciate what he can do with his hands.
All right. Third question I got, how long did it take to implement this workflow to your clinic, and what were the challenges?
Okay, for me, it's a little bit of a different story, okay? I'm sure Tillman won't mind me saying. I actually started off with CEREC. So I bought my CEREC hardware and software before I even had the keys to my practice, okay? So I was lucky enough as an undergraduate 22 years ago to see CEREC, before CEREC 3D, okay? So two-dimensional line diagrams, and I was so blown away about it, I basically thought, when I get my practice, that's what I'm going to have. And it just so happened that the year after I graduated, CEREC 3D came out, I saw it, I had an opportunity, a bank gave me a loan and I bought it. And I didn't even have the keys to my practice. That's what I did. That was my USP. So when I set up my practice, it was going to be digital. It was going to be that, you know, unique selling point from day one. So I've been doing this since I bought my CEREC machine in 2003. So yeah, so 17 years. And when eksocad came out with chairside CAD, I can tell you, put my hand on my heart and tell you my CEREC machine is in my shed. I don't need it anymore. I don't use it anymore. Because this gives me flexibility. This is open. I was restricted with the closed systems that I had before. And as I said in a statement that I made earlier, open systems, open workflows. Some of my colleagues here that lectured yesterday said pretty much the same thing, that, you know, it's great as humans not to be restricted. We like to be able to have options. Variety is the spice of life. So I implemented my workflow 17 years ago.
All
Wanna
right.
hit play?
Thank you so much.
Any other questions? Okay, we're going
Not
to.
now.
There's a microphone coming over to you.
I have a question to your implant case,
Yes.
because the implant system you are using was a Frealit or something from Detray, or
Nope, it was Bredent.
okay, but your preparation is very deep down, and you're using only your abutment is an individual abutment or a normal abutment.
Okay, so there's a few
Because
different.
the problem for me is the cementation.
Yes.
That's what I want to know, how you will,
Okay.
or maybe you explain it later.
Absolutely. Well, I can start explaining it now. So the good thing is we're about to start looking at Exoplan, okay? And because these are real life cases that I'm showing, I'm not showing the demo cases. I'm going to speak louder over the machine. I'm not going to show you demo cases, I'm showing you real cases. So that particular case, I've got that patient's CT scan and real data here. And you will see why in that case that implant had to be deep. It was because of the bone loss that she had. And certainly not the ideal situation. However, there are a number of implants that are meant to be placed deep. So the componentry that I work with is NT trading. Okay, I don't necessarily use the generics or the implant manufacturer's own components. You can choose whichever you want. The reason I use what I use is because, again, I have flexibility. So when an implant is deep, I can go ahead and use eksocad's function to make a custom abutment. Okay, I can mill it in titanium and then put a crown on top. I then bought my cementation platform up. But you know, posteriors, I'm trying to do a lot of screw retained restorations where I can. And you may have noticed that even though that was a tie-based restoration there, the base part, the gold part, that effectively becomes your customized abutment. So you can bring that up and down. Remember early on in the step where I drew the circle, the emergence profile? So you can place that higher and lower in the software so that you decide where it emerges from the restoration. So that designates the crown portion from the abutment portion. Does that answer your question? Can we have the microphone back, please?
That was fine, I understand, but my next question is, because before you opened to make the scan for the implant,
Yep.
you use a special scan body, or for the gingiva, you have an individual gingiva former, or you have an gingiva former. You have an
Usually,
individual
yes.
gingiva former.
Yes.
And the space of the gingiva former you are using also maybe is in the database of eksocad. So for
Not the
when
gingiva
it's later,
No,
in
not
this
the
case,
gingiva.
normally if you have it,
Yeah.
it's much easier to scan, because
Absolutely.
what you do, you sign it, it
Yeah.
takes time, and the main problem is later on if you fix the crown, and if you have too much gingiva, it's very difficult that you have the right back position if you screw it.
100%, totally agree
That's
with you. So
maybe
what I
okay.
do in my hands, I'm an implant surgeon as well. So what I do in my hands is I will warn the patient. So we do a check appointment to make sure that the implant is ready to restore. We take our ISQs and things like that. But what I'll also do is I'll warn them that, listen, your implant is deep or this or that, depending on how we've left it. So where I can during surgery, I will place a healing abutment so that I don't have to put the patient through further anesthetic and so on. But there are situations, let's say with grafting, when we can't or we don't want to. We have to close over completely. So that's where I would usually do a situation where in the UK we call it uncovery or second stage surgery, where you make an incision, you push everything back, put in your healing cap, let it heal, and then that makes this kind of process easy, because then you pick up the soft tissue profile that you've created with your hardware, with your healing abutment. Yeah, you pick it up with your scanner. The other thing to note is that, as I said earlier, Itera has a certain scanning protocol for implant cases. Different scanners will have different scanning protocols as to when you scan the scan abutment, and when you scan the soft tissue. So it's really important that you follow their workflow, and then when you dump that data into eksocad, it's seamless. It's very, very easy. If you come and see me later, I'll show you real cases. Any other questions before we switch to a whole different platform? We're going to look at Exoplan next. Nicholas? Larry? Oh, gentleman over there, can we have a microphone, please?
How do you cope with altering the vertical dimension? You mentioned that your patients have to do a strong bite to have, in order to have good contact points. And what else happens when there's a small change in the vertical?
Do you mean a change in the vertical because the crown is too tall, or do you mean a change that you're purposely trying to bring in? Purposely. Okay. Well, that's where the show distances option on here is great. So you can graphically see the amount of space that you've got because the legend on the screen tells you what the colors mean. So if you're purposefully trying to raise the bite, let's say for instance you're doing a quadrant and you're doing a case where the patient is overclosed and you're trying to build them up. I've done many like that. Again, come and see me later, I'll show you real cases. So what I would do there is, firstly, you've got to warn the patient, this is what we're doing, this is how it's going to feel later on. So what you would do is you still get the patient to bite in ICP, you collect the actual data that you've got, but then what happens is there is another function in eksocad which is auto-articulator. There are ways to get it to open up the bite, and you can say, well, I want to modify it so that this is the new bite. Very easy to do. What I've shown you guys today so far in this first hour is wizard mode, okay? It's the mode of eksocad software, and it applies to Exoplan, it applies to DentalCAD and to chairside CAD. This mode gives you a straightforward workflow. It guides you through it. But in expert mode, you can pick up any element and change it at different times. So if you look at the various forums, Exocad Experts, which is run by Waldo, I run Exocad Worldwide, lots of people will show cases that are complex, which have been done mostly in expert mode. But you know, I'm thinking that I've got a lot of new users here, so I'm going to show you the straightforward steps. But what you're asking for is something that I'd modify by opening the bite, build the restorations to that new bite, and then fit them accordingly. So I might do one quadrant one day, and a couple of days later I do the other one to build it back to the new bite, and that's how you can raise the OVD by 1 or 2 millimeters, however much you want.
Is there the possibility to work with a leaf gauge to open up a space?
Yeah, absolutely. If you did that, again, there are various different scanners on the market, intraoral scanners, where you can actually input different bites, okay? And then what will happen is, I tell you what, let me show you. Can we switch back to the design screen? Alrighty, so we're on the design screen. Up here is the magic button that says Expert. As soon as we click on Expert, it will give me a variety of different options available, okay? So if we go to the bottom of the screen, you can see these are some of the steps that we went through already, but also you can go ahead and align the model differently, you can change the original data, you can change the relationship between the opposing arches. All of that is possible, but I'm trying not to complicate the situation right now. So the software is powerful, believe me, it is, and you can run away with it. So when I teach chairside CAD-CAM to any new users, the last thing that we teach is a few elements of expert mode, and then we leave them to get on with it and do 30, 40, 50 restorations, and then as a reseller they'd ring me and say, right, I'm ready, let's take it to the next level. Okay? Any other questions from the room? Anything from online, Michael? Okay, in that case, we are going to switch things up and we're going to move to Exoplan. Let's shut down some of these screens. All right, so welcome guys to Exoplan Galway edition. Okay, so this was talked about yesterday, but it hasn't been released yet. I'm one of the beta testers for Exoplan, which is why I'm able to show this to you. If you look on the screen, you'll see this is the new tooth map. This is the new job definition screen. It's kind of similar to what we've seen before. And what I'm going to do here is I'm going to input the patient's name. The notes section there, this is great for practices where you have multiple practitioners using the software. So you could put in notes about what the implant case is, or you can put in the notes about which practitioner did it, and so on, okay? So as I said to my colleague over there, we are going to use the same case, real life data now, and you'll see why her implant was deep, because we're going to bring in her CT scan and we're going to look at how we use the Exoplan platform to go ahead and design this case for predictability. That's really important. That's why we're doing this kind of digital dentistry when it comes to implants. It's about practical and predictable implant planning. Okay. So again, I'm going to just highlight which data set that we have here. And what I'm going to do is say that our upper jaw is our antagonist. Click on OK. If I hold the Shift button, I can mark everything in the arch really quickly. In the lower jaw, again, we've got 7 to 7. These are our adjacent teeth. So again, click on the opposing side, the adjacent side, 7 to 7. And our working tooth here is the 4-6. You saw that. We've just done the design of the restoration. The difference here is we have a different selection of options here. We've got anatomic crown. We've got the ability to design bridges as well. So if we go ahead and do anatomic crown, and we'll just say, well, we're going to do a temporary restoration in PMMA. Is there an implant? Yes, of course, and it is going to be screw retained. And we go ahead and click on OK. So that is pretty similar to what you saw already. Okay. What's really important here is that we tell the software where the data set came from. So the guys at Itero very helpfully let me scan this case last night, so I've prepared it for you already. We'll go ahead and click on Save there. And we're going to click on the first option there, which is implant planning. You notice that the surgical guide option currently is grayed out. We can't switch to that just yet. So we're going to go implant planning. Now this that you just saw on the screen, that's Exoplan's DB element. Now we're going to go into Exoplan's CAD element. Warning there, like I say, this is a medical prototype, so what I'm going to show you is not going to be used in a patient's mouth. Okay, so load meshes. A mesh is an STL file, so it's just another way of describing a data set. Okay, so upper jaw without ditch, there we go. Lots of warnings coming up here because it is prototype, okay? I'm not trying to show you it's a prototype, I'm trying to show you the power of the software. So let me just highlight a couple of things that are important here before we continue. My lab on a daily basis takes on cases from dentists all around the UK for the production and design and production of implant guides. So I can give you a bit of an insight. I've seen data from probably 15, 20 different CT scanners. A couple of things that's important if you're using Exoplan or any implant planning software. One is that before you do a CBCT scan of a patient, look in the mouth, look at your proposed area and ensure that if there are lots of metal restorations around there, that either you see if your CBCT software has metal artifact reduction. If it has, switch it on please. If it hasn't, you have no choice then but to raise the dose to the patient, because otherwise what happens is all of that dose gets soaked up by the metal and you have problems with planning. The second thing is the amount of data that you collect. So you will see in a moment what we will be doing is we'll be correlating CBCT data with intraoral scan data. Now in the UK, it's very, very strict about how much the radiation dose is to patients. So what's happening there is that they're doing tiny little sectional CBCT scans. Now, if the patient doesn't have adjacent teeth or maybe one adjacent tooth, that makes data correlation very difficult. So when you're planning these kind of cases, or if a third party is doing the CBCT scan for you or the intraoral scan, discuss with them. You know, talk about the case before you put the patient through X-ray dose or intraoral scanning. It's really, really important. It makes this next bit much easier. So the next thing to know is where you put the data. So I've put everything on my desktop here. We planned this yesterday so that we knew where it was all going to be. So typically in our work scenario, we have a server where we keep all of the intraoral scans and the CBCT scans and we match them together, and that way it makes it easy. What Exoplan has done here is it's taken that CBCT data and it's recognizing that there are 160 slices in there. This is raw DICOM data. Okay. So from that raw DICOM data, the first thing that happens is that you've taken this 3D data set and it's asking you to create a two-dimensional, like a sectional OPT, panoramic radiograph, okay? And the way we're going to do this is we're going to line up this curve, okay? You can see in the bottom panel there that there's a horizontal line, and as I scroll down in the top panel, you can start to see the right mandibular section come into play, yeah? Now, next thing we're going to do is we're going to use these control points in the top jaw, and we're going to start drawing a line through the middle of the proposed arch form. So we're basically creating a modified field of view, okay? And you can see what's happened there in this particular case is now we can see the sectional panoramic data in the lower jaw. On the left-hand side there, I have a noise threshold for my X-ray, so you can really see the X-ray clearly. So just to reiterate, this is not a periapical image. This is data from the CBCT that's been modified to make your planning easier, okay? For colleagues in the room that can see this, these in the lower jaw under her extraction site were actually osteophytes. So we had this analyzed and so on, and it was found that it was absolutely safe to place the implant in this particular area. Okay, so I clicked on next. This is Galway edition. It's a little bit different to what other people may be using. This is the CBCT data, which is rendered. So that's the soft tissue over the top, and we're going to show you how that gets used. So a few different options in Galway edition. Not many people have seen this, but we can align two different CT meshes, or in this particular case, we're going to align the CT data to the intraoral data. So as soon as I clicked on next, it said, okay, tell me where the rest of the data is. So now I load the lower jaw, okay? So here we go. So we have our two different data sets. So this is the case. This is the one that we're actually milling the crown for absolutely right now. On the left-hand panel, you can see my CBCT data. Right-hand side, we can see our intraoral data. And you can see I have to abide by UK regulations, so it's a small site, so we've done a sectional CBCT here, okay, to keep the dose to the patient as low as possible. Now, what the software is asking me for is 3 points of correlation between both data sets. Now, it's important for these 3 points to be as far away as possible and accurate. So you can see the first point is a red dot on the mid-buccal aspect of the lower right 7. I'm now going to choose another point. Now, another learning point here, this is a few years old, this data set. Nowadays, I would make sure that this patient, when they're having their CBCT taken, they have separation between the upper and lower jaw. So either a plastic bite fork or a cotton roll, because if I'd had the patient with their teeth separated, I would be more easily able to pick points of correlation. So 3 points, and we try to pick exactly the same 3 points on both data sets, and we go ahead and click next. This is a new feature. I'm going to skip over that. All right, so what you can see here is it has already gone ahead and overlaid my intraoral data with my CBCT scan data. On the right-hand side now you have 3 images. Again, this is from raw CBCT data. And what's happening there is that we can see different cross-sections. The green line represents the intraoral data over the CT data. Okay. Now we're going to make this even more accurate. This is something that the developers have come up with, beautiful feature. And it's actually called mark feature regions, okay? So rather than just points that correlate, what I can do is I can use this and color in elements of the teeth and say, well, you know what? These are really important points. I picked these particular points because these are either side of my proposed implant restoration. When I hit on OK there, and then click on next, the software uses what I would describe as heuristics. I mean, it worked really fast there, but it's basically wobbled one model set over the other until it aligned it very, very carefully. Now, you've seen the colors that eksokad likes to use. In this case, blue means very, very accurate alignment, and you can see the deviation scale in the lower of the screen there, lower left of the screen. You can see if the more blue there is, the more accurate the correlation. And this is vitally important for what we're trying to do here. This is millimeter accuracy. So we go ahead and say, yeah, that's acceptable. We can move forwards. Exoplan and chairside CAD, by the way, are medical devices. And that's why the accuracy level and this attention to detail is so important, because these two software packages are put in the hands of practitioners for the creation of restorations that will go directly in the mouth. It's a little bit different to a lab situation. Okay, the next stage, guys, we are going to look for the mandibular canal on this side. And the way I do this personally is top right-hand side of the screen, we have our rendered CT data, and I can see that my mental foramen is right here. So if I click on that with my mouse cursor, my scroll wheel, in the main screen there, what happens is it zooms into that position, okay? Now, if I use my right mouse button and move across, there I can see my exit of my mandibular canal. And what I'm going to do is I'm going to start putting clicks in here, very similar to other implant planning softwares, but in my opinion easier. Now if you look on the lower right hand side in the orange panel, you can see the cross section. I can bring that into the main screen and just carry on putting in my mandibular canal. I can zoom out and you can see there's the data set. Okay. Now if I want to be really safe, or if I'm scared, I can go ahead and increase the size of that mandibular canal with this slider here, because that becomes what's called a collision object. So the software will warn you if you come within a certain distance of that mandibular canal. If I go ahead and click next, everyone with me so far? Any questions? This is a little bit different, but now we're coming to a part of Exoplan which is actually really similar to what I showed you already in chairside CAD. Remember I said there is some continuity between the two packages. So the software is asking me to place the mesial contact of the 4/6. I'm going to click there, and you can see it's proposed a tooth. For those in the room that have paid attention, you can see on the bottom left-hand side, again, I've got a library. And that is from my favorite library. It's generic. If I click on there, you will see all of these different libraries, just like I showed you in chairside CAD. So you can choose an appropriate tooth library that matches with this particular case. So here I've got myself a proposed crown, and I'm going to just leave it like that for the moment and go ahead and click next. Now things start to get serious. Okay, now we've got a lot of different data up on the screen. We've got our proposed restoration, we've got antagonists, we've got our working model. On the right hand side we've got CBCT data and a whole bunch of lines. Those lines orientate the different panels that are on the right hand side. So this is a really nice feature here. Again, if I use my scroll wheel on my mouse and go ahead and click on the center of that 6, look at what happened. So this is really intricate implant planning, guys. This is restoratively driven implant planning. So what it's done is, you can see on the right-hand side, the proposed restoration over the bony ridge. Okay. So there are many colleagues still who are asking their laboratories to cast impression, produce a stone model, wax up a tooth on there, and then on that they suck down a stent, and they use these kind of processes to go ahead and design where they may or may not be able to place an implant. I haven't done that for more than 10 years, probably 15 years, because of this kind of data, where you're not placing an implant where a technician can make a tooth look really sexy with wax. You're placing an implant where the bone exists, and if the bone doesn't exist, you can then plan to do some grafting. So watch what happens here. As I move that proposed restoration, which I can now scale, again, like so, holding the shift button, I can bodily move it lingually. Now watch what happened on the x-ray, and then I can tilt it. So what I've done is I've placed that proposed restoration over the middle of the ridge in such a way that I can say, well, where's the safest place to place the implant predictably, utilize the bone that I've got available with respect to the adjacent teeth. And if I go ahead and bring in my antagonist, and I turn up the heat on the antagonist, I can say, well, if I can design the tooth like this, so can the technician. So we can maybe turn it out a little bit on this side. You see? So we're proposing a restoration in 3D. This is why I showed you chairside CAD first, because we can see it from the inside, we can see it from the buccal, we can see it from the lingual, okay? And we've got a pretty good tooth placement there. If we look at how that looks over the bone on the right-hand side panels, then we can say, well, yeah, that's pretty good, because we're proposing a screw retain restoration here, and we want to ensure that the screw axis goes through the middle of the crown for the most strength, and also that the implant is in the middle of the bone. Okay, next stage. So this is a stage where we choose from our massive library of implants that are available. Again, eksocad has been talking for a long time to a lot of partners in implant dentistry, and they have a huge catalogue of different implants available. Now, it's so big that the easiest way to search it now is just to put in a name. My colleague asked earlier, what implant was this? Well, this was a Brilliant Blue Sky, actually, in this particular case. So if I go ahead and click that, when you click on an implant manufacturer, it reduces the list down to their range. Then you click within their range, and you can then see the diameters and the lengths. And this is the new kind of search tool, which is going to be released in the Galway edition. Okay, so we've got quite a wide ridge there. I'm going to go ahead with something like a 4.5 by 10. Let's see how that looks. So if I click on 4.5 by 12, click on OK, it gives me an STL, an accurate STL of an implant, and I go ahead and move my cursor over to the right-hand side of the screen, and I can propose it in the bone. The screen here, or the element here, which is not, let's say, the planning element, is the orange one up at the top. That was our rendered data. That was our extracted data, and that forms the sectional OPT, so it's two-dimensional. The planning should be done on the blue screen, the green screen, and the main screen over here. So let's say we go ahead and left-click and place that implant right there. I'm going to remove the CT data from here to make this easier for you to see, okay? And what we'll do next is we will look at all different kinds of cross sections, and I think it'll take me maybe less than 5 minutes to finish this planning element, okay? So I will use the OPT just to say, well, I don't like that there. I'm going to move the whole body of the implant distally, so I literally dragged it and pushed it backwards. The next thing that I can do is I can say, well, I'm going to switch to my main screen now. I'm going to just move that across so my screw channel is in the middle of my crown. Watch that wherever I change anything on any of these 4 panels, it changes in all 4 of them. Okay? If you have an implant system which has an index with either 6 sides or 3 or 4, 8 sides, or whatever it may be, you can now rotate that. Okay? And when you rotate it, you will see the STL file rotating on the screen, and that may or may not help you with your planning. What I've done there is I've clicked on my implant crown right here to center everything in the right place, and now you can see that all of them are centered. In the brown screen, lower right-hand side, you can see the outline of the crown over the implant, so I'm smack bang in the middle of my crown, and I could choose to leave it like that, or I can carry on modifying it. One thing to highlight here is on the main screen you can see this halo. We were talking about safety before, so it's really important for you guys to understand where the safety elements are built in. So if I click on the top left-hand side, implant safety distance, I can switch that on and off. Okay? The way that you actually set up your safety elements is right here in settings. So at the moment, the default from Exoplan is a safety distance of 1.5 millimeters. But if I'm a little bit more nervous, I might say, you know what, I don't want anything within 2 millimeters of this implant. Earlier I said to you that the mandibular canal becomes a collision object, and I think Michael Kernan actually highlighted some of these things when he showed Exoplan yesterday. So let me show you what happens if you hit any collision object. Everything on the screen turns red, and you wouldn't be able to proceed with it. So easy to see warnings. and they make it really easy for us to do our planning safely. So that's now got a 2.09 millimeter safety distance. I think where that comes into play is where you're doing multiple implants next to each other, where for restorative reasons you don't want the implants too close because you won't be able to build an emergence profile, and for safety reasons, for bone loss reasons, a variety of different reasons. So it's great to be able to set that up and it shows it to you graphically, but it's also sometimes useful to be able to switch that off and just see the raw implant data and zoom in and out. I hope my colleague over there can see now this particular case. She had low bone density. You can see that here in this screen. And this patient also had issues with the osteophytes and various different things. So this was a guided case, and we used guided surgery to actually go ahead and place the implant in such a way that it didn't hit those osteophytes. Let's go ahead and click on next. Okay, next point of choice is this is kind of like the fabrication of the surgical guide now, okay? So what's happened now is I've clicked next, our implant is in position relative to our design tooth, and what that green thing is up on the screen is a sleeve, and that particular sleeve is from the Braident system. Many of the different implant systems will have their own guided surgery sets, and Exoplan has collaborated with all of them to ensure that if they're prepared to share, their data sets are already in Exoplan. Really, really helpful.
Gulcan, should we ask some question that came in between?
Absolutely, fire
Great,
away.
Great. First
I have
question.
some tools if you need some tools, Nicholas.
Can you use the planning data to design a provisional restoration?
Absolutely, yes. So if you're working either with a lab or if you've got chairside CAD as well as Exoplan, what you can do is you can take your design file and give it to your colleague or use it yourself. And yes, absolutely fantastic for immediate loading cases because there's a nice correlation between the two software packages. So yes, you can. Whether it's for immediate loading or later loading, yes, you can.
Second question, does the software support alignment of fully endotolus cases?
Fully?
For me, it's a difficult word. Toothless endotolus.
Galway does, yes. The current version that is on release is for tooth-supported guides. In the future, the company is developing other types of guide fabrication. Absolutely, yes. So it's coming in the future, and Exocad will decide when.
All right. Third question I got is, can you view the tie base at the time of planning?
At the time of planning your implant, there are tie bases in the library. So the answer would be yes. Me personally, I don't use them, but it may be, and maybe Mike and Tillman can answer this because I don't use this element of the software, but it may be that yes, you can bring that in at that stage. Tillman's right.
Yeah,
there.
actually you can. There's a fairly extensive library and it's pretty cool. You can even do complex operation like putting an angulated multi-unit abutment already in during the planning. Then you can rotate it to see which rotation of the multi-unit you need to get actually an optimal result prosthetically.
In yesterday's live surgery case, they showed that. Yeah. All right, let's carry on with the design. I gave you some insight earlier about the kind of cases I see and how to CBCT scan and things like that. This is also a really important element here, especially if you're going pilot guided and you're using generic sleeves rather than the implant company's own guided system. Often if you're using the fully guided surgical set of an implant company, what Exoplan will do is it will not allow you to modify the height of the sleeve. So you can see a couple of really big arrows there, and those arrows designate two different measurements. One is from the top of the sleeve to the apex of the implant, and the other arrow is, let me zoom in, is from the top of the sleeve to the top of the implant. The important one here, the vitally important one for safety reasons, is the long arrow. So it's from the top of the sleeve to the apex of the implant, so that you can produce surgical guides that allow the practitioner to drill to full depth. Okay, so this is for pilot guides. Drilling to full depth means that you have to designate the height that's there. Where does that height come from? That height comes from knowing your surgical tools. Okay, so let me give you a clinical example. When you're at the front of the mouth, you've got loads of space. you can use a pilot drill of pretty much any length. Access is not an issue. As you go further back in the mouth, these pilot drills that come in your implant sets, well, they're of a fixed length. And a good implant company will give you pilot drills of different lengths so that as you get further into the back of the mouth, you have space. Well, this is where you tell Exoplan what the length is of the drill. So for instance, here we've got 24, and you could change that. You could make it 20, and you'll see the sleeve goes down. And what's really important here is if you look on the middle right-hand panel, you can see the position of the sleeve relative to bone, not relative to soft tissue. Soft tissue doesn't matter here because you're going to raise a flap, or like yesterday, you go flapless. Regardless, you need to ensure that that sleeve is relative to the bone level. So in this particular case, I believe that's at 20 mils now, and that works well. And I know Braden, and I know they provide a 20 mil sleeve. Different diameters are available here as well. So Braden is a 2.3 by 20. So let's go ahead and leave that there and click on next. Next thing, again, very important. So this says approval of planning. This is the end of the implant planning part of the software. The next part of the software is called Guide Creator. It's another module. So I have clients around the UK who use the implant planning element, and then they'll give that planning over to our lab, and then we'll use Guide Creator to do the fabrication, the 3D printing. So if at this stage the person that's been using the software is happy, you click on I confirm and agree. And what it's doing in the background is creating a detailed PDF report that is either useful for the planner to give to the surgeon, or for the surgeon to put in the patient's records to show that here's my due diligence, here's what I've done to keep this patient safe in this process. And I will show you those PDF reports at the end. Any questions before we move on to Guide Creator? We have one just over there. Can I have a microphone, please?
I would like to come back to the matching the data, CBCT and the intraoral scan.
Okay.
You were able to zoom your picture to see how precise the fitting is?
Are you talking about the fitting?
Between intraoral scan and CBCT scan.
Okay.
You have a 3-point matching, and
yeah. So when you do the correlation of data sets, it gave us a color scheme there, and the color scheme represents the deviation of data. The more blue there is, the less deviation there is. So when the software said, is this acceptable? Is this not acceptable, but I will continue anyway? Or should I discard the alignment and go ahead again? It gives you the option of doing that. And the reports would tell you as well. The reports would tell whoever's reading that report as to, did you follow the process? And you know, it's all about safety. It's about patient safety at the end of the day. So it's important that you don't click next, next, next and carry on. This requires precision. So yes, there is a way of zooming in and knowing that. If you come and see me at the end, we'll go back to that step and I'll show you again graphically. All right, so what we've done now, guys, is we have gone ahead and proposed what implant position, and we know where the sleeve is going to be in relation to the implant. So that sleeve will be later embedded into a guide. Now we're going to design the surgical guide. First thing that we're asked to do is to look at the sleeve mount. Now, what we're talking about here is elements to do with 3D printing. So whoever's going to create this guide for you really needs to be involved, because down at the bottom here we have something called radial sleeve offset. That's to help whoever's placing the sleeve in the resin to make it tighter or looser. We have different design elements. The big red tube up at the top, this is our clearance height. What's the clearance for? It's to ensure that you can get a handpiece over the top of it, right? So in the mouth, you need to ensure that the software has given you space to bring that handpiece in. So we can change our size of the sleeve mount over here. I would like that to be shorter. The reason why, the clinical reason why, is because we need to get irrigation to the implant site. So if you have something that's really close fitting and tight, because of where the irrigation comes from on an implant handpiece, you would not get irrigation to the bone. So that's really important in guided surgery, to keep enough space for coolant. Let's go ahead and click on next. When we click on next, we see there's our original model data, but it's brown in certain areas. And what that is that's Exoplan marking the undercuts that are available. Now what we need to do is we need to tell it what the path of insertion will be of this guide. Okay, so typically what I do and the way I ask people to design this is that you look from above your path of insertion and you look for physical undercuts. Now think about this clinically. A tooth is missing. So if a tooth is missing, there are going to be undercuts depending on when the tooth was lost. There could be natural undercuts on teeth as well as undercuts in bone. So this is how you help the software in saying, well, that's where I want to be able to place it in that direction, and use that direction to now block out the undercuts. So there are two buttons here. We say set insertion direction from view, and what that's done is removed all of those brown marks, and when I hit apply, it is now recalculating the undercuts relative to that path of insertion. And you'll see that the green arrow that was on the screen has disappeared, and a new one will come along shortly. Okay, the next thing that you see is our model now looks a little bit different. Now, what the software has done here is that it has blocked out the undercuts. This is like a digital way of, in a lab, when a technician is about to make a special tray for you, they create space, right? They create space by taking some pink wax and they put it all over the teeth, over the model, before they make anything on it. That's what this is. This is like digital spacer over the model so that you can get your guide to actually fit down. The rest of this kind of comes into personal preference. You need to design and manufacture a few guides, try them in to decide how tight or loose they are. It depends on a variety of different factors, but the first one is, where are the undercuts? So the undercuts are nicely highlighted for us in color. There is an element there, it was shown yesterday, where you can freeform and you can add or remove block out there to make it tighter or looser. We're coming to the end now. This is where it becomes really quite simple. And what I'm going to show you is the easiest way to create a guide on this particular case. So what I'm doing is I'm looking at one of the adjacent teeth. The instructions are right there on the side, and it tells you to basically start drawing a map. And I'm going to double click. So I've basically put a ring around that number 7 tooth. I hope you can see that if I show you from all different directions. I'm going to now create another element, which is the forward element. Again, with a number of clicks, I switch over onto the lingual side and carry on. And a double click at the end. And again, we've got a ring. Now on the left-hand side panel, you can see where the thickness is of the guide that we created. Usually I'll go to around about 3 millimeters. And if I hit apply on there, look at how quickly it's now created a guide. Now, what I've done here is I've left this a little bit too high. I need to bring this down because the software is going to merge those 3 elements to create one guide. So the element in the middle holds the sleeve. The element at the back is for support. And all 3 of those need to be merged together. So I've changed the line position. If I hit apply, it's now gone and extended that guide around. Okay, 3D CAD CAM, looking from all different angles. You could even look from underneath. Okay, everyone with me so far? Michael, you're looking confused. Is it a difficult question that came? All right. So let's go ahead and click on next. And the next thing, Michael Koonin showed this yesterday, is the ability to put windows in the guide that you create. One of the other colleagues that was lecturing yesterday was talking about the importance of this, and you saw it in the live surgery as well. You saw it several times that without having windows in a guide, how do you know that the thing is fully seated? Sometimes these things are really tight. So, you know, if the thing is lifted by 1 millimeter, your implant is not in the planned position. So really important to put in your windows, and Exoplan makes this easy. So we have various shapes. That's a rectangle. We have round ones. We can place text as well. I think it was Uli that showed yesterday when his lab made the guides for the live surgery yesterday. When they're doing upper ones, they actually embossed the patient's name in there. That's often useful. We're keeping this one quite small, so I'm just going to go ahead and design it in a simple way. So like with the other elements of design, I'm using the control key to move the and rotate the rectangular block around. If I hit this button here, preview, it will chop it out and it will show me, there's my window. So my technicians who make our drill guides would say, well, don't put one in the 7 position, I'll drill it through with a handpiece, it will be easier. But for you guys, I'm going to try and show you another way. We can put windows in at different angles. We can rotate them around, and we can pretty much cut out a block anywhere we want to. So let's have minimum length. And we can actually put this on the buckle side. Well, I can try. Now, shortly what we're going to do is we're going to turn to our colleague over there, that's Udo at the 3D printer. And since we've been milling today, we are also going to be printing as well. So let's have a preview of that. So there you go, we've got a little window on the 7, we've got a bigger window anteriorly, and if I hit next, this is where the software is now merging everything together, and we get a final opportunity to change things. My colleague over there asked about correlation and how can you see it. eksocad likes to show you things in full color. So have a look at this. So what it's showing us here is that the thinnest elements of this guide are in bright pink, the thickest elements are in blue, and we have ways and means of changing this. So typically the weak points on guides are where you drop down into the surgical site, and you can see that here. If I switch off the colors, you can see there's a potential weak point here. So what I can do is I can go into freeform, and I can just go ahead and add some material here to thicken it up. It's just as simple as I was doing with the design of the crown earlier. Remember I said to you that there's continuity between the eksocad platforms, so that if you've used one, the next one becomes more intuitive. So I've just added a nice lump of material there to thicken that up. In the middle there you can see the hole that's been proposed, and watch, if I switch on True Smile here, so True Smile exists in Exoplan as well, it gives you a visualization of how that guide might look when it's in a clear or semi-translucent resin. So if we're happy with that, we go ahead and click Next. And Exoplan is now writing another report. With each case it will generate 2 reports. One is your implant planning report and one is your surgical guide report. So they can be handed to different people. They can be used for given to the people that are designing, fabricating the guide. They can be used to put in the patient record, or both. So let's show you the end result. Looks like that. And we already have this design on the printer, so I'm going to go ahead and go to the printer and fire that up so that we start printing live, and then I'm happy to take questions from any of you. Brilliant, thank you very much. So this is the Envision 1 printer from Envision Tech. Again, partners with eksocad, and it's important that whoever's doing your printing knows about the intricacies of 3D printing. What's also important, I think Udo would agree, is it's not just printing, but it's also about curing and finishing. In our laboratory, whenever we produce any guide for anyone, we must have something to test it on. So if someone has sent us an impression that we cast and digitized, we ensure that the guide fits on there. If they sent us fully digital intraoral scan data, then we use a printer such as this to print a model and then make sure that the finished guide fits on there. And that way we can ensure that we're giving proper service to our practitioners, who then pass that on to their patients. So okay.
I calculated the cost. The material cost will be about 3.5–4 euros.
So what Udo said there was he's actually put that guide in 3 times in there. So it's going to print the same guide 3 times, and it was a total of 20.
Yeah, it's calculating now. It's at about 26–25 minutes.
25–26 minutes to produce 3 guides. Obviously, after that, there's some finishing and there's some curing time. Would you say about an hour, and you get some finished guides?
But the most time is waiting, because you
Yes.
waited for 25 minutes, and
Yeah.
the curing and the cleaning and the curing. What you said is very important, that you do that precisely. You have a medical device that
Yeah.
you produce here,
Precisely.
and you have MDR regulations in the
Yeah.
future, so you have to stick to it, to
Yeah.
the instruction of use, and it will take maybe 20 minutes, 15 minutes after you get it out.
What Udo said there is really, really important at the end. This is a medical device. Clients of ours say, should we keep these? Should we take out the sleeves? Should we reuse the sleeves? The answer to all of those is no. If you've gone to the trouble of designing these guides and planning these, it's a medical device that's actually owned by the patient. It's part of their record, at least it is in the UK. The rules in Europe are becoming stricter. It's vitally important that the resin that your printing partner uses is one that's CE marked if you're in Europe or FDA cleared if you're in the USA, so that it's a device that's safe to use in the mouth.
And you cannot just take any way of doing with this machine or with that resin. You have to stick to those regulations, and very important, you can also sterilize this. This is very, very important because you are in surgery in that position.
Brilliant. Udo, thank you very much. What I'm going to show you before we close is some guides that we've created already, because once you've created a guide, and as Udo says that you need to do your finishing and you need to go ahead and do your curing, then you need to place the sleeve. So the sleeves come from different manufacturers, can either be from the implant company themselves or they could be from third-party companies. If you want to take that to the camera, this is a finished guide for this exact case that we printed this morning. So that's how, just waiting for that to come into focus. Brilliant, thank you. So this is exactly the same design as I've just shown you live, where you've got an anterior window, you've got a horizontal posterior window. It's for this case, and the sleeves are actually, thank you Christine, are very, very small. They're obviously different sizes from different places, and I will attempt to show you the sleeves. So there are tools that are available. Usually a lab would do this, but there are tools that you can use to actually help put the sleeves in. Okay, and so this is like a cookery show, Udo says. Here's one we made earlier. Christian, do you want to do the before and after? So there's one with a sleeve in, there's one without a sleeve in, and that's pretty much exactly what we designed for this patient to do her surgery. So what we've covered today, our time is almost up as far as the live session is today. We've gone through a really simple case on how to use the iTero system to scan a prepped tooth, and we went ahead and we designed and milled a crown. We then took another case, which is this case, Lizzie's case, where we took her implant site. Again, we used iTero to scan a scan body. Thank you very much. And we went and designed and milled a screw-retained implant crown while you guys were watching. And then what we did is we took Lizzie's case and we took it backwards, and we took it from her CBCT scan data, merged it with her pre-op intraoral scan data, and we used Exoplan to design and produce a guide, which is what Udo's printing right there. That's me done, unless anyone's got some questions. We have one up there.
Hello, I have a question. We are from the Würzburg Surgical Group, and we are glad to use the eksokad and Exoplan works every day. And you showed pretty much the workflow we are using for our single tooth implantations and for creating the drill guides, which we do have great results, so
Brilliant.
thanks to that. But the question is, in the edentulous case this morning, we were shown a pre-drilling guide, which leads us to drilling holes that fix the drilling guide afterwards. We're wondering whether this is in the workflow to create this second drilling guide, or is this connected to the expert mode, or is it that I have to design two separate drilling guides, one afterwards? Do you maybe do you have an idea?
Firstly, thank you very much for the question. And yesterday's live surgery showed two drilling guides being used. I think may have even been three, actually. Okay, so two different drilling guides, and what they were doing is they were using the existing teeth to support those, because that's what we do with the current edition of Exoplan, is we're using tooth supported guides. But really, it's for the guys at eksokad to tell you what's coming in the future. I know what's coming because I'm a beta tester, but how much of that I can tell you is really up to the guys in purple.
Is this on? Yeah, okay. So actually, thank you for that question, because that's actually one of the features that were added to Exoplan 3.0 Galway a bit at the last minute, and that's part of the reason why it isn't released yet, because that's actually a feature many people inquired about. Sorry? Oh. That's actually a feature many people inquired about, to have a separate fixation guide, which can even be based on the scan of a denture, so it has anatomy, and I think that is what you were asking for, to have one guide just with the fixation pins. So you put in the fixation pins, you can then take out the fixation guide and put in the regular drill guide. It's an alternative to the protocol we saw yesterday.
So it was me that was asking the questions yesterday about why didn't you edentulise this patient and use anchor pins? And you know, they have their own reasons as to why they wanted to do that in that case. Me personally, some of the guides that I create, they have anchor pins in because the patients start off edentulous. The guys at eksokad are aware of this, and it's all coming. It's all coming soon. Any other questions? Michael, do we have anything from online?
Nothing from online.
Okay.
Everyone is satisfied, I guess.
Okay.
Are there some more questions from here? Then I would like to take the opportunity to say thank you for sharing your knowledge. I think that was a great presentation. You are a great teacher.
Thank you.
It's so easy to listen and to follow, and you're explaining so much. I think normally you can go through and design a crown within a minute maximum. Explaining it takes, of course, longer. I also want to thank our partners, our hardware partners, for giving us the machines here, Itero, VHF Stat4, but we have an open platform. That means we have many more possibilities for hardware that we integrate. For example, we have the chairside machine from IMS ICO here. You know, it's also a nice machine. There are many different scanners available, and of course, thank you to EnvisionTech for coming here with a printer, and you see downstairs there are also many more printers. So thank you to you all.